Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Salahuddin Abdul Salam and my matrix number is CN220333. So I'm from group 9 and my group members is me and the other one is my partner is Faris Daniel. And for this we are construct a project which is the project name is IDP that we call it Integrated Design Project. A three-phase induction motor starter data. So for this project, it focus on completing the star delta connection starter circuit, this is the electromechanical device without controller and with controller PLC. And this is for the logic control, which is we call it PLC. And for star delta starter is an electromechanical device used to start a three-phase induction motor in low starting torque by reducing the starting current. So for the next introduction, I will pass to my friends.
Hello, Assalamualaikum. My name is Faris Daniel bin Zulkifli. My matric card is CN220015. So I'm from partner with Salahuddin from group 9. So I will evaluate about the objective of IDP that used for three-phase circuit. So the first one is to analyze the PLC programming using different process description to control the automation. So PLC will give the command to relay. Then it will switch on the contactor that has the coil induction in it. So the automation is system. It used for various application industry. The second one is to design the star delta connection without PLC, without PLC and with PLC connection control. So if you use the PLC controller to make a star delta, we need a relay to give the command to the contactor. If we didn't use the PLC, we will not use the relay and the PLC, and we will transfer to timer. So that one is the robust. So the third objective is to reduce the current demand from the motor startup. So star delta starter are another device that may be used to reduce current demand during the motor startup. It is often to use for starting three-phase induction motor that can only be used when starting the motor without load and when the required starting current is relatively low. So that's all for the objective.
So for this part, I will explain about the PLC circuit with label and how it works. How the circuit of star delta with PLC working. So the first one is we have MCB, which is the first pole, second pole and third pole. And for the first pole is to for the first pole and two pole is for the single phase, and the T pole is for three phase. And then for the PLC, our group use CP2E. Which is for the PLC we have two channel, which is the input and the output. And then for the next item is AC to DC converter, which is the function of AC to DC converter is to transfer the AC current or convert the AC current to DC current, because from this circuit we have used a DC current and also AC current, which is the channel input and output in PLC use the DC current. Also the output of the relay use the DC current, and then for the start and stop button also use the DC current. And for the alternating current or AC current, it flow in main, star and delta and torque, and also in start and stop button. Okay, so how the circuit work when we on the supply first pole, two pole and third pole, the current will flow to the torque first, and then it will trigger two contactor, which is the main and the star, for 5 seconds. Until then it trigger the delta, and then the LED will light up, which is it show the motor is running to delta connection circuit or to the delta connection flow. And then when we pull the stop button, all of the operation will be cut off, and then the motor also is stopped. And then for the trip function or trip LED, it will light up when the motor when the current in motor is overload, and then the thermal overload function is to trigger the trip upon the motor current. And then that's all for the working and circuit label for star delta circuit with PLC. That's all.
For this part, we will explain the experimental setup of the circuit star delta without PLC and how the circuits will working or running.
Star delta connection.
So for this circuit, we have a push button, and then MCB with 3 contactor and 1 timer, which is the first contactor is main, star and delta connection.
So dia akan ubah.
And then for this contactor and timer, when we set to 10 second, the current will run to the star first. Until then, it will change or transfer to delta connection.
Saya akan tunjukkan.
So like first we on the supply or MCB, and then we push the start button, and then we see the current first go to the star and main connection. Until then, it change to delta connection after the 10 second of the timer is running. Then when we stop the push button, then the current will stop, and then we test for the trip, and the LED for trip phase is light up, and then the operation is stopped.
So we will present about this software, the CS programmer. So this is the ladder diagram for star delta circuit to transfer into the PLC diagram. So first we will run the simulate online. So the simulate online, if we start, and then it will goes to the main relay, and it will turn on also for the star, and then it will count down for 5 seconds before it change into delta and LED to turn on, and then switch off the star by using interlocking. So first we will run the start button. We put the value into 1 because 1 is normally closed. So the first main and star will run. Okay, it count down until 5 seconds and then switch to delta and LED. So we will transfer it into the circuit PLC. So we will show how to transfer the file ladder diagram to the PLC diagram, to PLC hardware. So first solar will be turn on the MCB.
So we on the supply first, and then we on the MCB, 1 port and 2 port. Then we will transfer the data to the PLC.
So first we will run up the software. Okay, after it run up, and we send the file to the PLC. Okay, the coding to the PLC already transferred, and Solar will present about the circuit diagram.
Alright, so after the data or the program is transferred, the indicator light in PLC will turn on, which is the program has already success to transfer. And then we will see how the circuit with PLC, how the circuit of star delta with the PLC is run and is work. So first we will push the start button, and then we will see the main and star delta is triggered for 5 seconds. Until that, it trigger the delta, which is the current now flow in delta connection. And then for the stop button, the function of stop button is for stop all the operation, which is let's we see when we push the stop button. So the all operation is stop, which is no current flow in this connection, main, star and delta. And then for the tip LED, the function is when the motor current is overload, the function of TOR, which is thermal overload, will trigger the trip button. Let's we see when the operation is run. Then we test for the trip button. Then if the trip button is function, then the indicator for trip button is light. Okay, so that's all for the transfer program of PLC to the hardware circuit.
So first I will switch on the MCB. I will turn on it. And then I will turn on the single pole and two pole MCB before I turn on the three pole, because I want to test the circuit first before I run to the motor. So first we push the start button. So the main and star will connect. After 10 seconds it will change to delta. So LED light will turn on. So if I stop and then it stop, cut the current from the delta and main. So if I start again and then I pull the trip, so it will switch on the trip light. So first I will switch on the three-phase current to supply to the motor. So I will push start button and then the main and star will connect together to start the motor. So the motor will start. After 10 seconds it will change to delta. So the delta will give more current to speed up the rotation motor. So if I stop, it will turn off. So that's all. Thank you.
So for the first measurement, we need to focus on the reading of inrush current, which is in kilometer, because after the motor is start, for 1 second, the inrush current value will show up, and then after until 1 second the motor is rotate, then the current of the star will show, and then the delta current will show. Okay, so for the first, we on the three pole, which is three phase, and then we start, and then we see the inrush current. Alright, the inrush current show for the 1 second, then from main and star to delta, and then this is the delta current. And then for the next, we will measure the line voltage, which is the first one is voltage between red and yellow. So that's the value for voltage between red and yellow, and then between red and blue. And then between yellow and blue. And next, the voltage, the phase voltage, which is between red and neutral. And then yellow to neutral, and then blue to neutral. And then for the next reading, we need to measure the speed of the motor using the tachometer. As we see, the value is 1602.2, and then the current between each of the phase. So for the red is 1.27, and then yellow 1.26, and then blue 1.23 or 1.24. Okay, so that's all for me for the measurement of the three-phase star delta control circuit with PLC. Thank you.
So for this part, I will explain about the experimental demonstration without PLC, which is the three-phase star delta with no PLC. So first we switch on the supply first, and then we turn off the MCB or main switch, and then we set the timer to 5 seconds first, and then we see, and then we push the push button and see the motor. So the motor is running until 5 seconds, and then it turn and transfer to delta connection until we turn off the push button, and then the motor will stop, and then we set to 6 seconds, and then we push the start button. The motor will start until 6 seconds, and then it transfer to delta connection. Then we test for trip test. When we put up, the motor is stop running, and then the LED is light up.